Welcome everybody to video number 2. We're going to talk about, we're still in talking about exponents. We're going to talk about multiplying and dividing common bases eventually, but now we're still going to kind of get to evaluating expressions with exponents. So we're going to really kind of evaluate some expressions with exponents today. So we talked about the terminology of exponents, b to the nth power, and what does that mean? B to the nth power is really kind of this one here. B to the nth power is b, our base, multiplied n times together, and this is kind of a take-home message from the chapter. B to the nth power is b multiplied by itself n times. So let's evaluate some of these expressions, especially taking a look at negative numbers and a negative sign. If we take a look at a parentheses, anytime there's a parentheses, that exponent is going to work on that parentheses itself. Everything inside that parentheses is what that exponent is going to work on. And that what's inside that parentheses then is our base. So here's our base. Remember, base to the exponent power. Base is -3, and we're multiplying it together 2 times. So we've got -3 times -3 is +9. Now if you take the next possibility where there's no parentheses, if there's just a subtracting 3 squared, then that subtracting sign is just that, a subtraction sign. It's not part of the base. We're subtracting a +3 squared, so our base is +3, and our base is +3. We're multiplying it together by itself 2 times because that's our exponent. So the base, and we have to account for that subtraction sign at some point, so we have to say there's a -1 multiplied by 3 times 3, and that gives us a -9. So pay attention to where the negative sign falls. If there's parentheses, like here, the parentheses is our base, and the 2, the exponent, acts on everything that's inside that base. So let's evaluate some of these, especially the negative signs. Remember, I'll do the first one, we can do the second one, third one, fourth one on our own and check your answers. So what's our base here? Our base is going to be just the 5, because it's subtracting 5 to the 4th power. 5 is our base, 4 is our exponent. Exponent works on 5. So what is our terminology here? What's our expanded form here? This would be -1 times our base, 5, times 5, times 5, times 5. And we're multiplying it together. We're multiplying our base 5 times together because we're telling this expression tells us that 5 is our base, 4 is our exponent. Exponent's working on 5, and the negative sign is just simply subtracting all this. So we're subtracting, and we indicate that by subtracting or multiplying by -1 everything that's written here. 5 times 5 times 5 times 5 is 5 to the 4th power, and that gives us -625. Pause the video now and work on some of these yourself. See what you get and see if you compare that to what I get. Alright, so we've got a couple of more expressions. We've got -5. Now this is in parentheses. That means that this parentheses is the base. Everything inside that parentheses is the base. 4 is our exponent working on everything that's inside that parentheses working on the base. So this would be -5 as our base multiplied by itself 4 times. So it's -5 times -5 times -5 times -5. All the negatives come out to a positive sign, so that's positive, and then 5 times 5 times 5 times 5 is positive 625. And make sure that you're writing down questions as you get these. If you have any questions about these, make sure you write them down, take some notes, and we'll discuss them in class possibly. Or we will discuss them in class, so bring it up in class. Again, here we've got parentheses. Parentheses tells us that's our base. 3 is our exponent. Exponent's working on the base, so now we just simply write our base, -0.2, and we multiply it. Sorry, that's a -0.2. And we multiply it by itself 3 times, because there's our exponent telling us to multiply by 3 times. That should give us a -0.2 times 0.2 times 0.2. And that gives us a -0.008. This one, let's see, there's no parentheses here, so we're subtracting our base right here, base to the third power. Base is 0.2 to the third power. We're subtracting it. So we're subtracting it means we're multiplying by -1. And our base is 0.2, positive 0.2. So we multiply our base, positive 0.2, 3 times together, 3 times again, and we get a negative 0.008. So those are the three answers that we checked. I went through this one by, by instruction. These are the ones that you should have gotten. If you didn't get them, bring them up in class, go through them again with the video, and check out the book if you need. Those are the answers. Let's try to evaluate now. Another idea is we can evaluate expressions like this or terms like this for different variable evaluations or different variable values. So if you take a look at this, we can evaluate this. We can remember for these examples, we need to really remember what is the exponent and what's it working on. For example, if I go through this example, I say I've got 5a squared. The squared only works on the a because the squared is the exponent for our base of a. So we have to rewrite this as 5 times, well, if we need to, we can go over longhand and say it's 5 times a, and then we could write it out as 5 times, well, a is 2, times 2 times 2, and that gives us 5 times 2 is 10, times 2 is 20. So there's our example. We might not necessarily have to go through this longhand right here, but you do have to remember that the squared only acts on the a. So let's try, I tell you what, remember for the next few examples, remember what the base is, what the exponent is. What the exponent works on is the base. So what is the base and what is the exponent? Keep that in mind as you do the examples. Pause the video and do some examples by yourself, and we can come back and I'll show you how to do them. Alright, now that we've paused the video, let's take a look at what this would be. So let's take a look at the base. The base here would be 5a because it's inside the parentheses. Exponent is 2. 2 works on the 5 and the a. So if we need to, we can write it out longhand. 5 times a times 5 times a. And you could say, you know what, there's my base, 5a, multiplied twice. 5a times 5a. There's my base, multiplied twice because I'm squaring it. So what does that mean? Well, that's 5 times, let's go again longhand, 5 times 2, a is 2, we just fill in the numbers, 5 times 2 equals 5 times 2 is 10, times 5 is 50, times 2 is 100. And there's our answer. Should get that answer. Take a look at this one, 5ab squared. The squared acts only on the b, because the b is the base for the exponent here of 2. 2 does not work on the a, 2 does not work on the 5, because the base is b, 2 is the exponent. So let's write this out longhand. It'd be 5 times a times b squared is b times b, because again, here's our base, there's our exponent. Exponent works only on the base of b. I'm going to rewrite this as b. And now let's just fill in some numbers. This is 5 times a is 2 times b is -3 times -3, and here we go. We've got 5 times 2 is 10, times 9 is 90. That's our answer. This one we've got to, again, take a look at what we've got for PEMDAS, order of operations. We would take a look at a plus b first. And what's our base? Base is a plus b because it's inside the parentheses. 2 acts on the a plus b, so we have to evaluate a plus b first. So what we would do, if we're writing out longhand, it'd be a plus b times a plus b. We've got a plus b as our base, a plus b times a plus b, and now we can just simply evaluate that for a and b. Here's 2 and -3. 2 plus -3 times 2 plus -3 gives us 2 plus -3 is -1, times 2 plus -3 is -1. That gives us a +1, and there's our answer. Alright, we're going to stop here and we're going to go on from here. Any questions? Remember, write them down, bring them to class.